Hi Precalculus, this is question number 8 from the chapter 7 review. It says solve the given equation for 0 to 3 pi, so that's 1.5 rotations. All right, so we're going to take the equation cosine theta cosine pi over 3 plus sine theta sine pi over 3 is equal to negative 3 over 2. So the nice thing is the left side of it fits the build of cosine theta minus pi over 3, right? And so what we're using there is the cosine alpha minus beta expansion, cosine alpha cosine beta, plus sine alpha sine beta. And so that's equal to negative root 3 over 2. So just to make sure we're including all possible values here, if my restriction is from 0 to 3 pi, then I want to make sure I'm initially considering values from 0 to 3 pi. I want to consider values from below 0 because I'll be adding pi over 3 to them. So they could potentially make it as solution. So I want to consider values from negative pi over 3 all the way up to what'll that be? So let's just do this out. That's going to be 9 pi, so it's 8 pi over 3. So beyond 1.5 rotations. So, here I need to go from negative pi over 3 all the way. And it is including, so theta minus pi over 3. From negative pi over 3, so like negative 60 degrees, to 8 pi over 3, which is one complete rotation, is 6. Another 60 and another 60. So 360 plus another 120. Alright, so now when I write my solutions here, I can say that theta minus pi over 3, the angle, the argument, is can equal many possible values. And so let's consider what allows cosine to be negative root 3 over 2. So if I'm considering my unit circle, negative root 3 over 2 puts me at these two, so I'm just ballparking where they would end up. But negative root 3 over 2 for an x value puts me at these two values of 5 pi over 6 and 7 pi over 6. Okay, so those will be my initial ones. So in this case, though, I'm initially considering, so I need to consider values that are from negative 60, so that wouldn't work necessarily because cosine has to be negative here. And then I need to go 2 rotations, so I'd have 5 pi over 6, 7 pi over 6, 12 pi over 6, 18 pi over 6, so this is 17 pi over 6 would work as well. Potentially. Because 8 pi over 3 is 16 pi over 6, so we'd be right outside of the domain, so this actually wouldn't work. So the only two that might work are these two, even though we have a domain that's a little bit more extended. So let's see if those two work. So if I put it as 5 pi over 6 or 7 pi over 6, then that means theta would equal two values, 5 pi over 6 plus pi over 3, or 7 pi over 6 plus pi over 3. And so here we can get common denominators of 6, which means this is 7 pi over 6, because that would be 2 pi over 6, and here 2 pi over 6 would give me 9 pi over 6. Okay, so I'm imagining these are the only two values in 1.5 rotations, but I'm going to confirm that on Desmos just to make sure. So we have cosine x times cosine, I need parentheses in this case, I believe, pi over 3 plus sine x times sine pi over 3, and we want that to equal negative root 3 over 2. Oh, it seems like I might need parentheses around the x's. Not sure why the syntax is not reading. Okay, there you go. So here I might actually, because my solutions have pi over 6 as their denominators, I'm going to see if I can go in a little more detail here and see every pi over 6 and zoom in. I want to be from 0 to 3 pi. So from 0, oh, got one in too deep. Okay, 0 to 3 pi. Seven pi over 6, 18 pi over 7 pi over 2, 4 pi, 3 pi. Oh, sorry, 9 pi over 6 is 3 pi over 2. I did not simplify it. So I think we actually have each of the solutions we need. We've gone from 0 all the way to 3 pi, and so we missed that one that we were looking at, right? It wasn't in our domain. So it's just 7 pi over 6 and 3 pi over 6 is 9 pi. 9 pi over 6 is 3 pi over 2, so that is the better way to write it. Okay, and here we could kind of give it better notation as theta being an element of these possible values. Okay, hope that helps.